Hi guys, this is Mrs. Denton. Today we are going to work on lesson 6-2, surface area of cylinders. Grab you some notebook paper, follow along with me, pause the video at any time if you need to go back or look at something again or just have more time to work with something. Make sure you have a calculator handy as well. Okay, I want you to try these two warm-up questions. It says find the area, and you can use 3.14 for pi. Go ahead and pause the video if you need time to work. Remember your formula for the area of a circle. Let me go ahead and put that on here. Your formula for the area of a circle is area equals pi r squared. Okay, let's go ahead and check your work for these. Remember, we can put this directly into the calculator with our formula. So for problem number 1, we have area equals, and we're going to substitute 3.14 in place of pi. And our radius squared is 3 inches. Now I'm going to put that inside parentheses when I square it into my calculator. So I can put that directly into my calculator, and that's going to give me a total area of 28 and 26/100 inches squared. Remember, area is square units. Same thing with number 2. We've got our radius of 7 feet. If I apply that into my formula, I'm going to have area equals, and we're going to substitute 3.14 in place of pi. And I'm going to square 7, and I'm going to make sure and put that in parentheses in my calculator, so that tells my calculator to multiply these two values. And we get a total area of 153 and 86/100 square feet, or feet squared. Now we're going to apply this formula, the area of a circle, to some of our problems today. So you make sure you have that written down and ready. Okay, the key idea, or one of the key ideas in this lesson, is to determine the surface area of a cylinder. Now the surface area, otherwise known as a capital S, of a cylinder is the sum of the areas of the bases and the lateral surface. So think about a cylinder like a can, a soup can. We have two bases, what we would consider the top and the bottom. Those are both in the shape of a circle. And if I were to peel off the label of a soup can and lay it flat, I would have the shape of a rectangle. That is known as the lateral surface. Now, in our diagram here, you can see that if I were to take off that label or that outside edge of that cylinder, the length of that lateral surface is the same length as the circumference of the base, which is in the shape of a circle. So that's why I use the word circumference. Okay, so this right here is what we call a net. When we take a 3D figure and we separate it and lay it flat, basically. So we're going to call that a net of a cylinder. Now, our formula for the surface area of a cylinder takes into account the two areas of the base. Right here, we have two of those areas of a circle. That's why we have the 2 out in front of the formula for the area of a circle. and then the area of the lateral surface, which is in the shape of a rectangle. And remember, the formula for the area of a rectangle is length times width. So we're taking that length and using the circumference of the circle in place of L, and then the regular height in place of W. So the formula that we're going to use is S equals 2 pi r squared plus 2 pi r h. So we have the circles, or the bases, and the lateral surface, which is the rectangular part. Okay, I'd like to start each one of these examples by repeating the formula that we had on the previous slide. So we're going to have the surface area equals 2 pi r squared, those are our bases, plus 2 pi r h, that's the side or the lateral surface. So example 1 says find the surface area of the cylinder, use 3.14 for pi. So think about that net in that previous slide. If we took that apart, what it would look like, you would have your rectangular sides, you would have your two circular bases. So we've got to have all that in place. Now in our figure we have a radius and we have a height. So I'm going to go ahead and make sure I know which one is which. My radius is 4, my height is 3. Now I'm going to substitute those into my formula, which I wrote on the top of the slide. And we're going to start out with surface area equals 2. Now I'm going to put parentheses around my pi, 3.14. Then I have my radius squared. My radius is 4, so I'm going to put that inside parentheses as well. That's going to tell your calculator the order of operations to solve this in. Now we want to take our lateral surface, or the side, and we're going to take 2 pi again, radius, height. Now we can put this directly into our calculator. We're not going to have the S equals into our calculator, but everything else can go into our calculator with parentheses, with the number being squared, and with our addition. All of that put in correctly. Before you hit enter, you might want to double check and make sure it looks exactly like this. Now once you hit enter, you're going to have S is approximately, and we get 175.84, and we are finding the surface area, so we're going to take our units and square them. Now I wrote approximately because we are substituting 3.14 for pi. So we're using an approximate amount. And that is how you calculate the surface area of a cylinder using the formula. Okay, example 2. We do not have a diagram, but we have all the information that we need to use the formula. And once again, I'm going to repeat the formula for the surface area of a cylinder at the top of the slide. So we have S equals 2 pi r squared plus 2 pi r h. Now let's take the pieces of information that we need in our information. Example 2 says find the surface area of a cylinder with a radius of 3 inches and a height of 4 inches. Use 3.14 for pi. So we have a radius of 3, a height of 4. So we're going to put that into our formula. S equals 2 parentheses 3.14 parentheses 3 squared plus 2 parentheses 3.14 parentheses 3 parentheses 4. Again, when you put it in your calculator, double check, make sure you've got it entered correctly with everything included. And once you press enter, it will solve it for you in one step. And S is approximately 131.88, and we're working with inches squared. Now, if you have directions to round to the nearest tenth, you can do that. I'm rounding off to the nearest hundredth, that's fine. You can also round it off to the nearest tenth as well. You might even see directions for the nearest whole number. Okay, example 3. Now notice the question on example 3 doesn't ask for the surface area. It says how much paper is used for the label on the can of peas. So if we're thinking about taking this cylinder apart, remember we have the two bases. We take apart the sides to make the lateral surface area. And basically that's the area that's being covered in paper. So we are only wanting the lateral surface area. They're not asking us for the surface area of the cylinder, just the paper that's being used on the label. So we're only finding one part of our formula. And I'm going to write my formula at the top of this slide again, just as a reminder. S equals 2 pi r squared plus 2 pi r h. Now, if we're only wanting the surface area of the lateral part, which is the label, then we are only going to need this second part of the formula. So, to find the label surface area, we're going to take 2 times pi, which is 3.14, times my radius, and my radius is up here in the diagram. It is 1, and my height is in the diagram as well, and it is 2. So I can put this directly into my calculator. 2 parentheses 3.14 parentheses 1 parentheses 2, press enter, and we're going to get approximately 12 and 56/100 inches squared. So, answering the question, how much paper is used for the label on the can of peas? The label will use approximately 12.56 square inches of paper.